this question is about conservation of momentum. So the main thing we need to remember is that the initial momentum will equal to the final momentum. So the initial momentum, we're told there's a car with a mass of 580 kilograms moving at a velocity that we're asked to work out, hits a stationary van. So we know the momentum of the stationary van is 0. And then we're told what happens at the end. So what we're going to do is we're going to equate this initial momentum to what's happening at the end. So following the collision, the van is moving this way with 6.2 meters per second, and the car recoils. So it is conservation of momentum. We need to remember that momentum is a vector, so the recoil means that it's in the opposite direction, so its momentum is in the opposite direction, and it will subtract from the momentum of the van. So we've got 580 and we've got 1200. So the momentum, I can work those two out. So 1.6 times 580 gives me the momentum in this direction. So that's 928 kilogram meters per second in this direction. And then the van is 6.2 times 1200, which gives me 7,440 kilogram meters per second in this direction. Subtract one from the other, and I get that the total momentum to the right is 6,512 kilogram meters per second. Now go back to the initial situation. This momentum, this final momentum, must be equal to the initial momentum. Conservation of momentum. Momentum is conserved within the universe. So the initial momentum, only one of the vehicles is moving, and that's the car. So the momentum of the car initially is its mass times v, and we know what it's got to equal. It's got to equal 6,512 kilogram meters per second. So we can rearrange for v. We get pc over m. So 6,512 divided by the mass of it, 580. We divide those two, so divide by 580, and end up with 11.2 meters per second.